Okay. So since the beginning of the building science, we talked a little bit about why passive lighting design is better compared to artificial lighting. And we mentioned that it's free and it's natural. So even the physical characteristic of natural light and artificial light, they are different. People, humans always enjoy natural light. So cost, so things regarding energy efficiency, so it's free. Okay, so let's start. So I would like to start by this. What you see in here actually is the first paragraph of the introduction of the thesis of this guy. This guy is my co-supervisor when I was student in UTM. You can hear me, right? Because sometimes I talk 10 minutes and then someone, sir, we cannot hear you. You cannot see the slides. You can see the slides and you can hear me, right?
Yes, sir, we can see a slide.
And you can hear me.
Yes.
Very good. So, as you can see, if you read here, so for God so loved us that he gave, this guy is Christian, he's a believer, right? For God so loved us that he gave human the necessity to live, daylight, for free and inexhaustibly. Throughout the decades, many researchers have reasoned the light influenced human psychology and physiology and psychology. Without light, there would no living. So basically, it's true. Without light, for example, there would be no vegetation because vegetations they cannot develop without lighting. So basically, animals they will not exist, and humans probably will not. So light is very important in our daily life, not only in architecture. Therefore, light is the basis of all things to sustain. Remember, now we are focusing on natural light, so passive light, free light. We are not talking about artificial light. So there is no Lyman method, no. So therefore, light is the basis of all things to sustain. Light is the foundation for architecture as well, as esteemed by Le Corbusier. So he mentioned one day that architecture is the masterly correct and magnificent play of masses brought together in light. So light is really a key word in this sentence. Mass, the volume of mass of your buildings. So you play under light. So if you're just playing with the volumes and you forget that you are playing under the light, you are not following what Le Corbusier is saying here. All right. So the first part, we'll talk about factors affecting daylight. Today I will, in the end, actually, we'll do a quiz also. Quiz only maybe 20 questions just to warm you up for the coming quiz next week. So let's continue. So here we talk about the factors affecting daylight. As you can see, there is environmental factor, and the uniformity is a factor also, the uniformity of daylight, and obstructions that can affect the quality of daylight, and shadow intensity and direction of incident light. So always when we are designing and when we are taking consideration to daylight, we always try to supply sufficient high quality light while minimizing direct glare. You know what is glare? In the first or second class we talked about it. Veiling reflections and excessive brightness ratio. Now, regarding the environmental factors. So basically, one of the environmental factors is building fabric. So including the windows, the glazing in the windows, the size of windows, and the position of windows. So the orientation. So all these factors, they are under the environmental factor, main factor. So all these, they will have an impact in the end quality of light that you will get in your space. right? And there is under this so ambient environmental factor including natural plus artificial light, comfortable temperature. So basically, you know, light can have an impact to the human temperature because sometimes light is coming with heat, so it will have an impact on the comfort of the occupant. Uh, Of course, it can have an impact also on the working surface, so it depends on the quantity of light falling on these surfaces. Okay, let's see the second. So obstructions. So you know, when you are designing any building, always there is obstruction, either other buildings or trees or any form of structures close to the building. So they, for example, simply if the surrounding buildings they are white, the color of the buildings, so the quality of the light that you are designing for your project will be affected. So in the contrary, if the color is another color like black or brown, so the quality of the light in your project will be affected by these obstructions parameters. So uniformity, light uniformity is very known thing. It's like when we say lighting illuminance or luminance or daylighting factor. So when you say lighting uniformity is very known thing in architecture. So you have to remember it. So uniformity of light is expressed by the ratio of minimum illuminance in the room to the average illuminance measured on a horizontal reference plane. So basically this uniformity is consider only the illuminance level in one space, the interior, not like the daylighting factor we have to measure outside and inside and then do the ratio. So this one basically the minimum illuminance over the average of illuminance in a specific space. So uniformity is essentially dependent on the dimension of the room and the openings and any other obstructions to light. So and also the reflectance of surfaces enclosed in the room, glazing type here as it is mentioned. For example, here is an example regarding the uniformity of lighting. So this one is poor uniformity because if you calculate the ratio between the dark, the less, where there is less illuminance, and you compare it to this, here there is, it's like the interval is very low here compared to this one. But here, this one, as you can see, many areas that have very low illuminance compared to the middle here. So here the uniformity is high, here is poor. As you can see, since it's ratio, so basically as you can see, it can be a percentage. So the more it's close to 1 or 100% is good. The more is less, it's not good. So please remember the light uniformity. There is even some software that calculate the light uniformity in your space, so they can simulate the light uniformity. Now we are talking, remember, we are under the environmental factors, right? So here, regarding shadow intensity and direction of light. So for the perception of the solidity and surface texture of objects, a reasonable shadow intensity is required. So how? So shadow intensity is generally generated by the lateral incidence of daylight into rooms from the opening. For example, even the working position should be arranged so that hand and body shadow do not fall on the working surface. For example, here if we are using artificial light, so generally we try not to make it, the angle of incidence of this light should not create too much shadow where you are writing, otherwise it's not efficient that way. So here regarding lighting considerations. So as you can see, there is three main things that we consider. The implementation process, which contains, for example, if the design option that I want to select regarding, is it costly, is it practical also, is it energy saving, and the quality of light. Now we have to consider also the lighting quality. So for example, the space and workplace consideration. So what kind of tasks will be in the specific space, and what is the lighting quality that we are looking for. And also light distribution. Do we need, for example, a uniform distribution in the space? For example, parking, we don't really care a lot about the lighting distribution compared to a mall, for example. And on the other hand, lighting quantity, always there is standards regarding the amount of luminance or light that should fall on the working plan. So always we have to consider this also. So part 2, do you have any questions? Okay, no questions. It means you understand everything. The following slides are very important. So because as I mentioned many times, the work of architect is about taking the best decision, and always there is a limit number of decisions, maybe hundreds and maybe even thousands. That's why nowadays we try to use softwares to help us to find the best decision. But always when we are focusing on passive design, as you know, there is passive design strategy and there is active design strategies. So what is the difference? Young Woon Kan, what do you mean by active techniques or active strategies and passive one? Yes, I cannot. You are not talking.
I'm not talking.
Sorry?
No, I'm actually thinking. So question is, what's the difference between the active technology and techniques and
What is, okay, let me repeat. What is the difference between active lighting design strategies and passive lighting design strategies?
hold on, I think active is
Come on, you are using Google.
hold on.
You should not use Google. Why you are using Google? You have to use your mind.
I think
It's okay not to know. It's okay not to know. It's okay. Nobody born know everything.
yeah.
But it's not okay not to focus. That one is not okay. If you focus and you don't understand, you can ask question and problem is solved. And this question is easy actually. But I think I have to ask you questions like this in the quiz. So active technique, anyone knows? Anyone can answer this question? Nurhan Muhammad. Last time you didn't switch on the camera, I remember. So please answer this question.
I see. Okay, I switched last the camera.
Okay, sorry about that. Okay, so please answer this question.
I think I don't answer.
Really? I thought. Okay, what about Mirias? Since you are expert in passive design strategies, maybe you know active design strategies.
I think passive is the one who take advantage from nature, climate. The passive one, passive design.
It's not accurate definition. Always when you have to learn something, when someone asks you to define or to compare two things, you have to try to explain and then you have to give examples to support your argument. I'm sure you have examples in your head, but you didn't give me.
Now I say like the passive design is the one like it's kind of similar to a sustainable design, right? Like taking advantage from climate, from nature and stuff. So
Yeah,
this
but
one is a passive.
give me examples, because you give me example. Okay, let me explain so we don't waste too much time. For example, now in my room there is a fan above me. This one is active. Why? Because it's a machine which is consuming electricity, and you have to activate it on or switch it off. However, this one is passive design for cooling. So this one is passive cooling. I'm not consuming any kind of energy, only my body. So in terms of electricity, I'm not consuming. And generally, when we say passive in architecture, it means we don't really consume electricity. And active, always in active, we use systems that they will consume electricity. For example, anything. For example, air conditioners. They create cold air. They cool your building, but they are not. They don't cool it passively. However, a window. If you open a window, the air will come and it can cool the building passively and for free. Aircon, you have to switch it on and you have to pay money every month, right? So active system, it's where we use system that they will consume energy to provide either cooling, or there is active cooling, there is active lighting, like artificial lighting. So that one is active system. No, but the passive design strategy, that's why I told you this lecture is important, because we architects, our first priority is to make the passive design of our building perfect. And after that, of course, sometimes if using only the passive design strategy is not enough. Sometimes you don't have any other, you cannot run away. You have to bring the air conditioner to ensure there is comfortable air in your space, etc. So architects, they have to focus on the passive design strategies because they stay basically the whole building life. So not like air conditioners, if you remove it or something, but if you put a window in a building, generally it will not be removed until the building disappears. I was asking this question, I thought it's very easy. I mean, I thought you know the answer, so I didn't expect I would start explaining this kind of things. Anyway, but please remember this, because an architect has to know what do we mean by passive design. So now in here it's passive. Normally here passive design strategy. I'm not sure where is the word passive, but basically it's here. But here is passive, we mean. So passive, you know, many techniques that we can use, our strategies. Orientation is one of the passive design strategies. If you are just designing your building, if you really do good study, which, you know, orientation is 360 degree, you can orientate your building, right? Of course, if you keep, doesn't mean you have to try 360 degree and you see maybe the impact. At least we see north, east, south, you know, at least 8 orientation maximum. So orientation, it can have an impact, of course, on your building. Of course, it depends on the elevations and how much glazing area, etc. So second thing, also kind of passive design strategies which usually link to the roof. Things regarding, for example, atrium. We can use atrium to bring light from above the roof. We can create courtyard. For example, I know in Nigeria, I'm not sure if there is students here in Nigeria, they use courtyards a lot. In my country also, they use courtyard. And here in Malaysia also, I believe they use courtyards. So courtyard, you know, passive ventilation. You will create a passive ventilation for free. Don't need to create mechanical ventilation or. And space planning, so it's one of the passive designs, can be also in passive design strategy. For example, if you have a window in front of you and it's bringing natural light, and suddenly you bring a shelf or refrigerator and you put it in front of the window. This means you are not doing good in space planning. You are making obstacle for your source of passive design, passive lighting. That's why passive lighting, you have to know how to organize and how to plan your space. Well, things regarding colors, so maybe this one has less effect compared to the others. So the colors you choose, you know, white and black. The black absorbs too much heat, light, and heat, and the white is the inverse. Position of the window, so is important also. So regarding passive, this one, you are not consuming any type of energy if you select the position of the window is this or this or this. Type of opening, if it is horizontal, vertical, if it is curtain wall or it is a window, and if it is skylight, maybe skylight, it's better to be here in the roof, but anyway, it's still an opening and is in the roof generally. And the glazing material, you know, if you use double glazing or what we call it low E glazing, the performance of the glazing is different. So some type of glazing, they will not let heat to enter to your space. So it's important also to consider glazing. As you can see, and the last one is shading devices to protect your glazing, to protect your windows, for instance. And plus to that, passive lighting systems. There is passive lighting systems. We will see them all. So basically, we'll go through all this 8. We'll see examples. Please, if you downloaded this PDF before, please download this again, or because as I mentioned many times, I always try to update. So this is the last updated version. It's in CN. Okay, let's continue. So now orientation. I think we explained orientation. We have at least 8 orientation, right? Including east, west, south, and north, and we have the orientation between each 2 of these. So just by orienting your building, the amount of heat coming to a specific elevation will change. Amount of light as well, of course. So when we talk about roof lighting, so as you know, in airport, for example, generally they use roof lighting because the floor plan is very large, so they cannot, the windows or the opening, the lateral ones, they will not have an impact on the middle of the airport. That's why always when you look up in the airport, you will see always there is this kind of skylights here. Or even atrium sometimes, like the International Airport of Singapore, I believe. So it's very sophisticated in terms of daylighting. So here we are continue talking about roof. As you can see here, we are showing you skylights. And all these, remember, it's free, it's passive. Nothing is consuming energy to provide lighting quality like this. That's why in design studio you have to apply these kind of things in the very beginning. I mean, you have to consider these things before you start telling what kind of lighting fixture or this kind of active systems. You have to focus on these things. So this, you know what is an atrium, right? An atrium, it can be covered like this, and can be open without glazing. But of course, without glazing, it means you have to be careful to rain, and sometimes you have to be careful to solar radiation, because in Malaysia, you know, most of the time sun is above us. So this means solar radiation is a big danger. So this means if you want to close it using glazing, you cannot use any type of glazing. You cannot use one layer of glazing. Otherwise, if you don't have a system, passive system for natural ventilation, it will be a problem. Because generally, you know, in generally we can make even this atrium glazing. It can open automatically depending with there is sensors. They will measure the heat of the space inside here. So if it is very hot, they will open to ensure natural ventilation. Sorry, natural ventilation. And if it is rainy, maybe they will close. So it depends on the weather. They will perform. But that time, of course, there will be kind of active system, but it's not a big problem because they will not keep opening and closing every time. So it's maybe one or two per week or once per day. So it's not a really passive active system. We can still consider it passive. Even though there is motors, they will work to open it. So roof lighting, as you know, there is some techniques to, for example, because if the sun is here, as you can see, if it is normal glazing, the sun can go directly to here. So basically, because generally we use atriums where there is a building, and we want to ensure at least considerable amount of lighting in these spaces, because these spaces, they have windows we can open without any problem. But these spaces, if the building is too high, imagine, I know those, they live in this atriums, sorry, this condominiums like Ankasa or Ponchak here close to UCSI, you know, there is kind of atriums and they are open. So basically, the more you go up, the more the luminance will increase, because, you know, sky is above us, right? But down, it's darker compared to. But at least it's good. That's why if you see many windows in this condominium, they are open toward the corridor where there is the atrium. So it's good for ventilation and good for lighting. So many birds with just one stone. So as an architect, imagine if they didn't make in, if they did, for example, let's say this building, there is no atrium here. It will be the interior spaces, they will be very dark. Always we are switching on the lighting. So every day you are consuming energy. So in the end of the year, we will find we consume too much energy. Just because the architect didn't do a good decision. He didn't consider what type of solutions we can bring, and it should be passive one. And as you know, atrium generally we can even plant trees and vegetations. So we can really, it's really good even for passive ventilation. Okay, so let's continue. As I mentioned, so we can use reflective materials, so to make sure the sunlight will go down and lighten these areas. You know this one, right? This one is Petronas, right? So basically, this Petronas, so this one is like it's like an atrium, but it's covered, as you can see. So it's like maybe 70% or more, 80% is covered. But they still use the natural light here. Imagine if there is nothing, this one doesn't exist. So basically, you will see too many artificial light in here. Switch it on in this time. As you can see, it's very simple decision. Just to consider the natural light, we forget about switching on electricity. And this kind of thing will remain until this building disappears. So basically, it will remain until the whole life of the building. And generally, we don't really need too much maintenance like artificial light. You need to change it. And it's natural. Space planning. So as I mentioned in the example I gave you, so the proper introduction of daylight into the interior. So this to satisfy the biological need of the mind, plus body for a change of comfort, to provide visual variety with controlled luminous contrast. So space planning is very important. So where to put, for example, the area where the tasks will be performed, position of the window. You can say it has relation with the space planning, position of all furniture, because you know where the position of the sun rays. So based on that, you can organize your space. It doesn't mean you just I open the window. It's enough for ensuring equality daylight in my space. I still need to think the position of all the furniture and what will happen in my building. So as we mentioned many times, so you know everybody knows color. So the color can have it will reflect light. So if it is clear color like white, or so it will reflect light. And dark colors, you know, it will absorb more heat and it will absorb light also. So color, it has also, it's kind of a passive thing we are using. We are not consuming electricity to change color. Even though there is, you know, there is some windows they can change the color, right? But it's chemical, it's not electrical windows. Position of windows, I think this one is clear. So the fenestration strategy, so the admission of daylight into structures is frequently accomplished by windows, or it can be also, you know, curtain walls, especially commercial buildings. So the position and the size of the window is important. So if it is vertical or horizontal, top through the roof, like skylight, or just a window, normal window. And type of window here, well, so position and type of openings. I think these ones you are very familiar with. As you can see here, same design, we can use different configuration of windows. As you can see here, it's very dark, but when we insert multiple windows sides here, so it becomes clear. We can also use this kind of design options. So the advantage of this one is like a light shelf. So basically light will come like this, and this area is white, so it will reflect light like this. And this one also is using the color which can reflect, and it will reflect again the light until it tries to reach maximum area. So the advantage of this compared to this one, basically, if the glazing is not good enough, so a lot of heat will enter. However, this one, since it's a reflection, so the first reflection heat will be lost here in this surface. So basically light will go through, even though it's the same area of window if you compare this to this, but just the using light shelf with reflective material, we can innovate and bring other solutions to the table. So you in Design Studio, you should not keep thinking just making an opening. You will see more examples actually, because we as architects, we have too many options actually for passive design. So here you have to know that for vertical windows, useful daylight penetration is up to a depth equal to 2.5 times the height of the effective window head above the horizontal surface of interest. So basically, normally this window, this A should stop here because the window is just here. So the useful daylight. So useful daylight will only reach a distance of 2.5 meters, the height of the top of the window above the work plane, usually taken at the desk. Well, you know this. In a standard office building with a window height of 2.5 meter, this means maximum of about 5 to 7 meters. So as you can see, this one is very basic kind of rule of thumb, but it's very important. So it's saying if you have a window, for example, let's say it's 1 meter height. So basically, the useful daylight will reach only the height of this, which is 1 meter multiplied by 2.5. So basically 2.5 meter it will reach. After that, the light which is reaching here, some light will reach here, but it will not be really useful. So it will not be really helpful in doing your task. You understand? Look, useful daylight and daylight uniformity are also very known things in architecture. If you read any book regarding daylighting, you will find this concept. So it's not something I'm giving you. So everybody knows that. This means you have to know. The students, one student has to mute the microphone. Okay. Okay, sorry. So for this one, the A should stop here. Okay, la. So this means, let's say, for example, you are about to rent a room in in Pontiac Bayan, close to UCSI. So if you have a room like this, and you have a window like this, so if the window it's about, let's say it's 1.2 meter. So if you multiply 1.2 meter by 2.5, if you find the wall is exactly here, so basically your room will be full of useful daylight. So basically, if there is no clouds in the sky, so probably you will enjoy the daylight without switching on the artificial lights. Of course, it depends on the orientation of the building, also of the window, because you know. But here we are considering diffused light, so it should not be directly opposite to the sun, for example. Because sun, if it is sunset, it can even reach here. But that one is not useful daylight anyway. Do you know this building? Lum Wen Hua. Do you know this building? Are you expert in
No.
Are you expert in Lumion? Because your name starts with Lum.
No.
You don't use Lumion?
I know what is it. Yeah. Seldom
You
use.
Okay, so do you know this building?
No.
What about Merit? Marias. You know this building?
No, it's my first time though.
Sorry?
My first time.
I didn't hear you. You have to.
It's my first time.
You didn't visit Paris?
Paris, not yet.
So this building is in Paris, actually, so it's in France, and they call it the Institute of Le Monde Arabe. So the Institute of the Arabic world. something like this. So it's written here. Étudier le monde arabe. So basically, this building is special somehow because since we are talking about type of openings, there is horizontal and there is vertical, and skylight also is another type which is related to the roof, and there is dynamic or kinetic type of openings. So the building that you are seeing here, what you are seeing, the elevation is full of dynamic opening or kinetic opening or kinetic facade, they call it as a whole. As you know, the architect is Jean Nouvel, right? He's a French guy, French architect. He's very known. So basically, how if you go inside, you will find this system. So what you are seeing here, these things, they are this in the inside. I don't know if you know Musharabiyya or not, but in the Arabic world, they used to use this Musharabiyya, which is like a piece of wood which contains too many holes. So because you know, it's like they invented this thing which called Musharabiyya because generally in the Arabic culture they don't like women. They don't like to show. I mean, they don't like to go outside, you know, without that hijab and this kind of things. So there is this Musharabiyya. So women, they are able to see outside without others. They will see them. And the second thing, it can bring light. So that's why they use it in mosques a lot. You will find kind of wood, like decoration wood with too many holes or decoration. So it can let the air enter. It can let the light enter in kind of interesting way, and it will allow also those who are inside to be kind of in private space without they can see what is going outside, but they cannot see them. Anyway, so this is the concept of this architect. He wanted to use this Musharabiyya concept, but of course, in architecture you should not take something and you just plaque it. So he wanted to be innovative. He is a very big architect. So since since it's a museum, and you know, in a museum we don't like direct sunlight to enter to the space. So his idea was to use this Musharabiyya, this system, and develop like a mechanical system which will allow some or most of the opening. As you can see, it will open and close, but it will not open and close for fun. It will open and close depending on the quantity of light is entering to the space. This means there is sensors, they can measure the quantity of light entering, and depending on that, they will close and open. Of course, not only quantity of light, but even heat also, you know, always, you know, heat and light, they go together. So this system is full of sensors. So as you can see, as an architect, it doesn't mean you should or you have to always focus only on walls and windows. Sometimes you need to see how mechanical things they can work, how in order to get this kind of ideas. Of course, in order to make this idea real, of course it's real now. It's this building exists. It's not easy as you know. So basically, they have to develop a pattern which should be repeated in the elevation. I think you are doing similar things with Mr. Fahmy, building technology or CAD, or I'm not sure. Yeah, but of course, there is an advantage of this, but one of the disadvantages. Okay, first of all, is it passive or active? This one, Helen Lim Xin Yang. Do we call this passive design strategy or active design strategy?
I think it's passive.
You think it's passive?
Yeah.
What about Yong Won Kang? Why you are scared when I ask you a question?
Nothing. I think it's passive because using the sunlight. then you need hands to.
Okay, but what will move these motors? We need motors to move this, make it open and close. They will not close and open with magic.
Oh, is it? Oh, okay. I was confused. Okay, in this case, if this device was run by mechanic, the meaning they need electric. Therefore, I think definitely is an active.
Yeah. So we cannot say it's purely passive, and probably we cannot say also it's purely active, because you can say it's combination. It's hybrid system, which is using the passive light through an active system. And remember, the good thing, this active system will not keep, will not be active the whole day. So basically, it depends on the solar position, of course, this opening or closing will happen. So it's not like the air conditioner. In order to provide cold air, it should be on the whole time. But this one, it depends on the sun. So basically, it will not really consume too much energy. But it's still an active. This is an active system combined with a passive system, because the initial system, which is Musharabiyya, they call it Musharabiyya, is purely passive. But when they added this innovation, it becomes hybrid, we can call it. You know, hybrid, like hybrid car, like which use electrical and the fuel. Anyway, of course, this idea is implemented in many projects, not only this one. So you know this project, I believe. So it's Al Bahr Tower in Dubai. As you know, Dubai, the weather in Dubai is very harsh. So it's desertic area. So the the temperature, it can reach very high degrees. So it's very painful. So in order to build the building, just glazing, and you don't protect the glazing, it's really the biggest stupid idea on the planet. So you should not do this, even though I know there is many buildings that are glazing in Dubai, but of course they use very sophisticated glazing. They don't use the glazing that you find. I don't know, even double glazing doesn't work in this kind of climate. Anyway, it's so the architect also proposed to use, because as I mentioned, this guy also, his concept is coming from the Musharabiyya. As I mentioned, Musharabiyya is like decoration, like a piece of wood which has decoration. Okay, maybe I will just write in internet so you see what do we mean by Musharabiyya. Arabia. So this is what I'm talking about. So this one, they call it Musharabiyya in the Arabic world. You see here? I think this one is Pakistan, so Osama knows this kind of things. Yeah, here is very old one. So basically, you see there is kind of windows and they are full with that Musharabiyya. So those that are inside, they can see the outside without being seen with others. Anyway, let's go back to this. So this guy also, he brought the idea from Musharabiyya. So because generally Musharabiyya, they use it to protect from sun, to ensure privacy, and to create ventilation. So this guy, he took that idea, but he's using it only basically for lighting and heat gain prevention. So he wanted to decrease the solar radiation falling on the surface of the project. That's why this system also is mechanical, and it contains too many motors that they will do this movement. It's not for free, so there is motors, they will move this kind of things. And of course there is sensors. So it's not about pressing a button. So there is a computer which will do all the calculation. There is too many sensors on all these elevations, and depending on the sun position, sun, for example, is in the other side. And me, it's an office building. I would like to see. I would like people to see the outside. I want the view. So automatically, computer will know the sun is in the other side. There is no heat from this side, and we can get diffused light for free. So why it should be closed? Okay, so open it to a certain degree, of course. As you can see, it opens. There is percentage of opening. So this one is a hybrid system. You can see it's passive and somehow active, but you can say it's kind of 70% passive, 30% is active. Type of opening. So here it's regarding skylights. You know, skylights, there is many types just by changing the form. So you can have different amount of light coming and different direction where light can exceed your space. So as you can see, generally in passive design, just by simple gesture in your design, it will have a huge impact on your building. Now, we'll talk about glazing. You know, it's always an issue. It's always a dilemma because we want light, but we don't want heat in Malaysia. So if you just make openings and you forget about heat, this means you don't understand anything. And it's not good. You cannot forget about heat when you talk about glazing. Glazing, yes. So you should not take glazing as a source of view and natural light. Always there is the issue of heat here in Malaysia. So you know we can use that, and you know we can use double glazing to reduce noise, and of course it will reduce heat somehow, not that much. It will reduce heat. But actually there is more sophisticated technologies we can use, especially regarding heat, because if you build a building totally glazed, as buildings that we are seeing recently in Malaysia or in Dubai, and you just use normal glazing, you can cook chicken inside it. So you should not do that. So generally most of the buildings you see in Dubai, they are using what they call it coated glazing. They use kind of chemical materials. They make a coat on the glazing. So this is an example, the use of low E glazing. Low E glazing is used a lot in especially in winter, in countries where there is winter. In Malaysia also they use it, even though some people they say no, it's not good to use low E, because low E glazing is very expensive actually. But it's very good in preventing infrared radiation. You know, we mentioned there is too much electromagnetic radiation coming to the planet Earth. Some of it is UV, infrared, and some is the visible light, right? Visible light is good, but infrared will bring heat. So if we make a glazing which can let the heat go reflected, which is the infrared, and we let the visible light enter, it's a very good thing. So this is what they are trying to do. Those they are manufacturing this kind of materials. So this is how, for example, this is an example of one advanced glazing that is used in office building, for example. They call it low E glazing. It's not only just double glazing. You say double glazing is not effective if it is not coated. As you can see here, there is a soft coat low E, and it's double glazing, and there is kind of gas between them. They call it yeah, argon gas. So basically, if if you break it, so it kind of explodes because there is gas inside it. As you can see, it's like it contains many things inside. So it has an anatomy. That's why it's very expensive, this kind of glazing. But the good thing, as you can see, summer solar heat and UV rays stays out. They cannot enter. And winter home heat stays in. This type of glazing is applied for countries like Canada, like any country with they contain winter. So it's good for summer and good for winter also. But this kind of glazing, it's not good for Malaysia, I believe. What do you think? Because you see, they are saying winter here. We don't really have winter here. So in the next slide, there is a video which will explain to you, because actually there is two types of low E glazing. Let me share the sound. Please focus here. I will ask you questions. So watch this video. It's only 2 minutes.
Hello, I'm Glenn, the glass guy. So how do low E coatings on window glass work? Most low E coatings are manufactured by applying a microscopic silver coating. It's so thin you can't even see it. In fact, the coating is actually thinner than a human hair. Low E coatings are so thin that they are measured in a unit called nanometers. Take a look. You'll see that a human hair is 75,000 nanometers. By comparison, low E coatings are only 150 nanometers. That's ultra thin. Now, there are two different types of low E coatings: passive and solar control. Passive are best used in cooler climates because they allow some of the sun's infrared energy to pass through. Solar control blocks UV and infrared light from passing through while allowing visible light in. These coatings are ideal for mild to hot climates that are more dominated by air conditioning use. Let's see how these glass units perform using a special contraption. This is a Crookes radiometer. It consists of an airtight glass bulb containing a partial vacuum. Inside are a set of vanes that are mounted on a spindle. The vanes rotate when exposed to light, with faster rotation for more intense light, providing a visual measurement of electromagnetic radiation intensity. On the left is window glass with a passive low E coating. On the right is a window glass with a solar control low E coating. Behind each of these pieces of glass are heat lamps that will serve as our energy source, the sun. As you can see, the more energy that is transmitted through the passive low E coated glass, the faster the vanes move. But look at the solar control side. The vanes move much slower, indicating less energy is passing through. Now imagine if these were the windows in your home. Imagine not having to have your air conditioning on full blast to combat the sun's infrared energy. Or in the winter, imagine being able to harness some of the sun's warmth to keep your home warmer, but your energy bill lower. And to think, this is all possible with a coating that's thinner than this.
Okay, let me ask someone now. 10019551555. Hi. So what are the two different ELO glazing mentioned in the video?
Sorry, I can't hear so clearly.
I said what are the two type of low E glazing mentioned in the video? Did you hear my question?
Yeah, I know your question, but I don't know the answer because I not too understand about the video.
Really?
Yep. Because just now, honestly, just now when I saw the video, right, a bit lagging.
But at least you can hear the sound, right?
Also some blur.
You couldn't hear the sound?
A bit blur lah. But I can listen a bit lah. I know about the size of the low E and between the hair. That part I very clear, but at the backwards the part quite blur already for me.
Anyway, so actually in the video he mentioned there is two type of low E glazing. There is what we call it passive low E glazing, and there is what we call it solar control low E glazing. So what is the difference he mentioned? He mentioned that, anyway, first of all, low E glazing, they are made with the glazing which contains specific coating, which will increase the performance of the glazing, and this means it will not let specific radiation to penetrate, right? So now the difference between passive and solar controlled E-glazing, the passive is usually used in cold climate, he mentioned. Why? Because they can let some infrared radiation to penetrate to the space, because in cold climate we want the direct sun rays to enter to the space in winter, right? Not like in Malaysia. In Malaysia we don't want that because we don't have winter. So that's why in Malaysia we can use low E glass solar controller, so the second type. So this solar controller, it has a coating in the outside which will not let the solar radiation to enter, which means you can put this kind of glazing even in face of the sun. You will get natural daylight, but heat will not be able to get inside. This means it's very good for your air conditioner, because the more heat it enters to the space, the more energy your air conditioner should consume. So it's a very good thing. So this means I will ask you this question again in the quiz next time. Okay, next. Now, sun shading. I think everybody knows what do we mean by sun shading, right? So a piece of material, so it can be wood, it can be concrete, it can be steel, so which will create shading on your opening. So this is the basic thing regarding shading devices that we need, and it's passive. It's basic thing, and it's just a piece of wood or something, but it's very efficient because it creates doesn't let the solar radiation to enter to your space. So this means you will win in the end, because without this small parts you may pay too much money for air conditioner because too much heat is entering. Of course it can be horizontal or vertical, and even egg cracked, so there's many types of glazing. And it can be kind of louver system also, so repetition of shading devices, as you can see here. Of course, when it is louver and when it is when it is made as a louver system, it can obstruct the view, and also it can create glare during sun day due to contrast, because between, if you are inside, for example, between these openings there will be too much light contrasted in that area, so the brightness will be high. As you know, another advantage, for example, louver system, they can move generally, so we can move them either manually or it can be mechanically also. Now we will talk about passive lighting systems. Here are different passive lighting systems. So there is the prismatic glass. There is light shelves. There is heliostat. And there is light tubes. And there is anidolic ceilings. Jean-Loup, are you familiar with the heliostat? This one. Are you familiar with this?
No.
Okay, so as you can see, there is many options. You can okay. As you can see, there is many options that you can use in your design studio projects. So prismatic glass. So this technology is within the glass. So it's applied on 1/3 top of the window to divert the beam of sunlight. So beam, it means the ray of the sunlight upward to the ceiling, which will then diffuse it to the rear part of the room. We will see examples about each one anyway. So light shelves, here is the definition. And heliostat, here is the definition. But anyway, we will go through them one by one. So this is the one that we were talking about, this one, prismatic glass. So there is type of glass which is not flat. So it's designed in a way it can reflect the light, for example, coming from the sun here. It will be reflected to the ceiling just because of the design of the glass in your window. This one is passive, of course. You just need to buy the glazing, this glazing type, and forget about it. Install it and forget it. No maintenance, nothing. So this light will be diffused, as you can see, to the part of the ceiling, and from the ceiling it will go to the remaining spaces in your room. Or so this one, so it's useful for the interior that can't be reached by the day lighting from side window. Okay, let's go to the second thing, light shelves. So when you see anything like this, we call it light shelves. Please focus. These things, if you don't, what does it mean, light shelf? You cannot call yourself an architect. That's why you will see questions like this in the quiz. It's like you are a doctor in medicine and they tell you what is an ear, you tell me I don't know what is an ear, or what is an eye, you tell me I don't know. So again, so light shelf, so use of horizontal element, an extended transom across the window at the height of about 2100 millimeter with a reflective upper surface which directs the light up to the ceiling. So basically this is the simple way of doing it. This is a very simple way. As you can see, there is an opening here, a big opening. So we take kind of shading device or horizontal plane, you put it here, and it should be white. So the light, when it comes here, you know, the reflection angle of light is equal to the angle of incidence, right? So if it is coming in 40 degree, it will be reflected in 40 degree also. So when it is reflected, it can go inside the project, and it's free. So the other way around, we can make it outside. Outside, it can be good, especially because like this, it's two things. It's shading device. In one hand, we are protecting this part of window. In the same time, the surface of the window above this light shelf can still reflect the natural light to the inside. So, of course, this one, it can be more efficient, especially when we are afraid about the heat. Yeah, and there is some of other shapes. Since we know the behavior of lighting beams, this means we can even create specific shapes with specific angles in order to send the light beams to the maximum as possible. Of course, this kind of things depends on the region, because some areas, like in Malaysia, you know, depends on the sun path, I mean, and the orientation. Here are some images of this light shafts. So, for example, if this element didn't exist, you will see it very dark here compared to now. As you can see, this light, for example, here is coming because of the reflection of these light shelves. It can contain different levels also, not only one. Now, here is the heliostat. So the heliostat is used for roof lighting. Heliostat uses mirror to direct sunlight. So the keyword is mirror. We use a mirror and the motorized system. So the mirror will track the sun, and a fixed mirror can direct the solar beam downward where it may enter the room through a diffuser. As you can see, the people that are really doing a huge effort just to bring that natural light. You see, they are creating mirrors, they are using motors to control these mirrors. Why? Just to bring natural light. So as you can see here, too many mirrors. Of course, when we use mirror, we have to be careful to the direction of the mirror, angle, sun position, all these things, they have to be studied, not just put the mirror and that's it. So for example, here, there is kind of an opening in the roof, and we can put a mirror like this. If we really need we want natural light, we can put a mirror. So the light that will come here, we know the angle of reflection, it's equal to the angle of incidence, right? And the angle of incidence, we can get it from the sun path. We know in the sun path, we know always the height of the sun. This means we know the angle versus the horizontal plane. This means we can calculate the angle anytime, how sun rays will come. That's when we know that, we can configure the angle of this mirror. So if it is okay, so it will reflect here. There is another mirror here. So this mirror, it will reflect down here. So light will go down until your space for free. 10019555155. You are very happy. Did you feel you understood what you are saying? Do you like the heliostat? I think he's playing PUBG or... Anyway, please remember these kind of things. These kind of things generally more maybe in the cold climates. Because when we use mirrors, the reflection, it will be too intense. It can reflect even the heat. If you have noticed, if you take if the mirror is on your face, I mean, if you put a mirror where you see the sun, so the amount of light coming to your face, it can heat you. So this means the mirror, it doesn't really reflect only light, it can reflect even heat. That's why in cold climate, like in Russia, they use this kind of techniques a lot. And you know, in Russia, lighting is really valuable thing, not like in Malaysia. The lighting quantity, natural light, is too high compared to these countries. That's why always they use all the techniques. Now, in order to, so after seeing all these mirrors and all these reflections, the second part of the heliostat is this. So as you can see here, there is reflection. So they can create a system like this. Basically, it contains mirror. This one, it will diffuse the light. in your space. So for example, if you have an atrium, as you can see, this atrium is very small. So without this kind of reflection, probably it will not be effective. Especially we have too many windows here, and they are facing the wall. So it's really terrible design without this kind of things. At least we create this kind of things to improve the quality. Do you know this project? Let me share again because there's a video after that. Do you know this project? You know this project? Helen Lim.
Sorry, I don't know this.
Okay. Well, it's a project in Sydney. This one, maybe you know UTS, University of Technology Sydney, here. So, and this project is designed by the same architect, so Jean Nouvel, the one who developed the dynamic elevation that you have seen in the Institute of the World, the Arabic World. So as you can see, that architect is big architect, and he's always considering passive lighting strategies. As you can see, this is the second project. He's trying to do his best to solve an issue regarding lighting using natural light. Let me share again. So the special thing of this one, the special thing of this project, as you can see, you see this kind of too many mirrors here in this project, and apparently there is mirrors here also. This is the same project. This is the project that you were seeing, and this is the mirror that you were seeing above. As you can see here, there is another building contains apparently mirrors. So this architect is trying to do his best. He's creating many mirrors just to solve an issue. So when you see the video, please listen, you will know what is the issue. Okay.
I'm standing in front of a structure that's caused more head scratching, confusion and discussion than just about any other in Australia in recent times. It's been called everything from a NASA experiment to a projector to a sunscreen to an edible roof garden. What it is a heliostat, and it's unique. Let's go and take a look. This is the old Carlton United Brewery site, which now incorporates some of the most innovative, environmentally sensitive design ideas you're likely to see anywhere in Australia.
Yeah, the heliostat is unique to a residential structure. It is probably the only one that we know of in existence here and around the world. Essentially, the heliostat forms two aspects. The first is that it is used as a monumental architectural design element of one central park and very noticeable from a distance and when you're here at the site. And the second aspect is it has a specific function. It's designed to reflect light in the southern corridor of the precinct, which would otherwise be consistently in shadow. And it does that through a series of fixed and motorised mirrors that track the sun and reflect that from our lower west tower that sits approximately 100 metres beneath the static or fixed panels over the cantilever, and that provides the reflective surface to generate the light into the southern corridor. The heliostat, or the passive or fixed reflective panels, there's about 320 in total, or 1.5 metre square metre each panel, is fixed to the lower part of the cantilever. The cantilever itself juts out from our east building about 42 metres and is held up by 4 trusses that individually weigh approximately 90 tonne. So a very well-conceived and engineered and resolved piece of architecture. So at night, it actually forms the backdrop and canvas for a major piece of public art that we have here that forms part of the $8 million program at Central Park. And it is a light show by Jan Casale, and it's simply about 9 LEDs per panel that is constantly change and reflects the motion and aspect of Central Park.
So you can see, I believe, how much architects sometimes they spend too much effort to find solutions just to bring light, natural light. It's a whole structure, so it's not just a mirror, one mirror. It's a whole structure, as you have seen. It's integrated to the structure of the building. Yes. So as you have seen, of course, in the slides, if you click here, we'll watch the video on your own. So it's on YouTube, this video. I know probably in Teams it's not smooth. So if you wish to look to the video, you can just click on the link. Yeah, so basically the issue, why they did all these kind of things, basically, as you can, these buildings, they are new buildings. They created this building just recently. And they have noticed if they keep creating this kind of buildings, the public spaces here, they will be very dark. That's why they decided to make sure these public spaces, they will have enough natural light coming. That's why they created all this structure and all this heliostat that you are seeing. Because probably here there will be another project, maybe here another building. So this public space should receive a considerable amount of natural light.
I'm standing.
Okay, so the number 8, which is the last one, another passive system, which call it light tubes. As you can see, light tubes is somehow simple compared especially to the heliostat. So the idea always to direct light from the exterior until to your space using mirror, as you can see. As you can see, they are directing light like they are directing water, or using mirrors, of course, here. Since we know the Snell's law is regarding refraction, but reflection is very simple. So the angle regarding the incident angle of light is equal to the reflection. This means all the angle of mirrors, we can decide what it should be. So from above until it can reach to the space. So as you can see, this one, for example, is natural light. This one is not artificial light. So natural light for free and for life. Yeah, here just some images regarding case studies. Le Corbusier, as you know, as you can see, he used a lot the natural light. Of course, these artificial, but natural light always plays a role in his building. So please, when you are designing design studio, you should not forget about natural light. You cannot. Good architects always, they are very strategic in their design. They will not jump just to the artificial light, because natural light is always the best. Yes. So this guy is Luis Khan. See how he's playing with light and shadow. Here is another project. Of course, when it comes to natural light, always it has a relationship with the sun path. So if you don't have any idea how the sun will go through the day or through the year in Malaysia, you cannot take decision about that. That's why in Building Science 1, you learned how to study how the angle position of the sun in any time. So this is Toyo Ito. So all big architects, they consider natural light. And it's a very big mistake if you don't consider it, because generally you should demolish if you didn't consider it in the beginning. Here is an airport, normally Shanghai. This one is Singapore or China. Anyway, you see this airport is really, the daylighting is really efficient. There is no artificial light to switch it on, and only here maybe, but here it's totally natural light. Of course, because they are using very special roof. It's not just a roof like this. As you can see, there is kind of skylights, and there is kind of reflection. So of course, it doesn't mean a window it should be square and skylight it should be square. Skylights sometimes they can be like this. For example, as you can see, they are using prefabricated component here, and it's repeated. This is a museum. Of course, in museum generally we don't like the direct sunlight to enter, but we would like to see the natural light. Look to the natural light. You are not switching any light like this. Look here also. So this one is Yale University, USA. See, just small decision, it make a huge difference in the project. If you see the section, it looks very simple project, but look in the reality how the impact of the natural light coming from the roof. So this is the conclusion. It's 3:45. So daylight management is to provide adequate luminous level, visual comfort, and it should also prevent heat. So daylight is influenced by the general structure of the building, the design of the facade, like windows, skylights. It can be further extended by the use of special devices for redirecting or transporting light. So special devices, basically they are the passive lighting system that we talked about. So with the appropriate orientation, shade and control, room surface finishes, electrical lighting, passive lighting systems. So all these are necessary to achieve cost, equipment, effective, sustainable daylighting. So any questions? Any questions? So I'm teaching only 10 students or what? From where did you come? From below the chairs? Sorry. This is good background. Looks that I'm teaching you face to face. But well, I cannot see the other students. Okay, I think I have to take notes. These are the attendants, and I don't see them. I have to see the ones. Yeah, otherwise you are not here. It's like Star Wars, this one. So others, they are absent, right? So I will give you about 5 to 10 minutes for a break, and then I will do the quiz just to see how do you think. Just I mean, the official one is next week, the official quiz. Today is just to see. So maybe I will be surprised, I don't know. Okay, so see you after from 5 to 10. Okay, let's say 5 minutes, just 5 minutes.